Hey Geometry, welcome to section 10.8. In this section, we're going to look at equations of circles. So, since all points on a circle are equidistant from the center, you can find an equation of a circle by using the distance formula. Let x, y represent a point on a circle centered at the origin. We'll start with the origin, but then eventually we can get circles other places. So x, y is a coordinate on somewhere on that circle. Using the Pythagorean theorem of that x distance, x and y, x squared plus y squared is equal to the radius squared, we know that we'll have that point, that relationship. So this is like x squared plus y squared equals r squared. And so if we have some fixed radius we could plug in a number for r, and we'll actually have a relationship between x and y, and you could solve for x or y if you wanted to, but we don't actually have to for this. We have an equation that gives us, if we could plug in one, we could get the other. So now suppose that we have our center is not at the origin but at point, and we'll use some couple of letters h and k. And so in this case we can adjust for it. So we're not going to be going, x, the coordinates x are not going to be from the center anymore, but they are going to be from this point. So what we can set up is similar Pythagorean theorem. We can do this distance formula where we basically take our x coordinate and then find its distance from the point. So it'd be x, actually I'm going to call this the radius. Our radius is going to be the distance from that point, so x minus this coordinate h squared, and then our other thing is going to be y minus k squared, and that will give us a distance from that point, so that we can use our distance formula. You could then simplify, change this relationship. If you didn't want the square root on this side, you could actually square both sides and get r squared is equal to x minus h squared plus y minus k squared. And that will end up giving us a circle where we have a fixed radius and we have a center at that point. So the standard form of the equation of a circle with a center at h, comma k, so just a couple of letters there, hk, and radius r is, and so we do this, it's x, and I'm just going to flip this side, x minus h squared, y minus k squared, sorry, that should be squared is equal to the radius squared. And it's effectively just making sure that we are that correct distance away from it using our distance formula / kind of Pythagorean theorem. The standard form of the equation of a circle is also called the center radius form. For example here, write the equation using the center and the radius, write the equation for each circle. So we have a center at 1, -8, and a radius of 7. So we can follow this formula. You could do it kind of either way, but I'm going to do it this way. I'm going to write x minus, and this is like our h, this is like our k, and then that's our r. So it's x minus 1 squared, so it's how far we are from 1 squared plus how far we are, and that's horizontally, how far we are away from y, -8 vertically, so y minus -8, which ends up just being plus 8 squared is equal to our radius squared. And that sets up, so we have all the points that are that equal distant from, distance 7 away from that coordinate 1, -8. So the signs kind of change when we plug that in for that center, and that radius is squared. And I guess we're not technically done. We would simplify this by saying x minus 1 squared plus y plus 8 squared is equal to 49. And so if we write it that way, you still have to kind of realize that as a radius of 7. In this example, we want all the points that are equidistant from 0, 4. So we're going to do x minus 0 squared plus, and that's going to be how far we are horizontally from that point, plus y minus 0, so y minus 4 squared, that's how far we are from the 4, that should be equal to the radius. And so in this case we can count up this radius in a few different directions. We could either go, I don't know, up from 4, 5, 6, 7, that's radius 3 if we go out here, radius 3 if we go down here to 1, or radius 3 if we go back there to -3. So it's going to be 3 squared. So like, if we pick a point on here, wherever it is, it's however far it is horizontally squared plus however far it is away vertically squared, it should equal 3 squared. For that, it would effectively be that hypotenuse of a triangle. For that distance formula. So if we simplify this, this ends up being x minus 0, that's just x squared, plus y minus 4 squared is equal to 9, once we square that 3. All right, so another example, write an equation using the center at the point. So we have a center at 2, 4, and we want it to go to a point that goes through 6, 7. So they don't actually explicitly give us the radius in this case. So the first thing that we want to do is figure out what the radius is by doing effectively distance formula. So we can do -2 minus -6 squared plus 4 minus 7 squared, and then take the square root to get what is our actual radius going to be for this figure. So in this case, we end up getting -2 plus 6, so that ends up being 4 squared, so we get 16. And then the square root of, and then 4 minus 7 is -5, and so we get, sorry, not 5, 3 squared. This ends up being a 3, 4, 5, by the way. So we have 9, and so that ends up being a square root of 25. Square root of 25, which is a radius of 5. Square root of 5. And so on. So we now know the radius we want to be 5, and then we can actually go back and then set this up and do our proper circle formula. So we can do x minus, I want that center at 2, so x minus -2, so it's going to be x really plus 2 squared plus, and then we want y minus 4, so y minus 4 squared, and then we want that to equal 5 squared, which I'll just go ahead and write as 25. And so that would be our formula for our circle in this case. Similar one here, we want to figure out what that radius should be to get from that center of 3, -2 up to 5, 1. And so we'll have to do a distance formula, and so it's 5 minus 3 squared, or it's really just a distance of 2 squared, plus y minus y, so 1 minus -2 squared, so 1 plus 2 squared, and then we're going to take the square root. So we get this square root, and this is going to be our radius in the end. And so it ends up being 2 squared, so just 4 plus 3 squared, which is 9. And so we get the radius is going to be the square root of 13. I'm just going to leave it like that for a moment. We could figure out what that is as a decimal, but it is better to leave it that way. And I'll show you why here. So when we go to actually do our formula, it's going to be x minus our center, x minus 3 squared plus y minus -2. So it's going to be y minus negative is just plus 2 squared, and then equals the radius, which is square root of 13 squared. So in the end, our answer just ends up being x minus 3 squared plus y plus 2 squared equals 13. Our radius is actually whatever the square root of 13 is, but when we write out our equation, it's actually pretty nice that way. So that's how that one sets up. We can go in the reverse and we can graph this circle. So an equation of the circle is x minus 4 plus y plus 1 squared is equal to 9. State the center and the radius, then graph it. So our center is going to be at, it's x minus 4. So our center is going to be at 4, comma, and then it's x minus, so it's the opposite of this sign. So it's -1, because this was y minus -1, it ends up being +1. So that's our center, and then our radius is the square root of that. And so it's the square root of 9, which is 3. And so I want to draw a circle here centered at 4, -1. So 4, -1 looks like it'd be right about there. And then I want a radius of 3, so I'm going to go 3 points from there, and really just up, down, left, right is a good way to start this. So 1, 2, 3, I'm going to go through there, 1, 2, 3, going to be up here, out 3 to the left, 3 down, put me down there, and then I can kind of fill in and draw this circle as best I can. And that's that one. All right, and then use 3 points to write an equation. 3 tornado sirens are placed strategically on a circle around a town so they can be heard by all. Write an equation of the circle on which they are placed if the coordinates of the sirens are -8, 3. So -8, 3. I'll go ahead and plot that on here to help give us idea. So 1, 2, 3 up there. So that's 1 point. -4, 7. So -4 and up 7. And then finally, -4, -1. So those are the 3 points that I want to use to make a circle. And so we want to make sure that they are all kind of equidistant from some point here. So there's a circle here, and we want to make sure that they are all equidistant from that same point. So in this case, this one doesn't set up too bad. In other cases, this can be a trickier problem where you have to actually do like perpendicular bisectors and see where they hit to find the center. This one ends up being all right. If I kind of split this thing up here this way, it ends up being just right there in the middle, the center that we're talking about, because we went from here 1 below up to 3 above up to 7 above. So that distance ends up being 4 and then 4 to the left, and so we're equidistant from all those if that radius is 4, and then that point of center is -4 comma and then what do we have at +3 -4 3. So I'll write that out here. So we're going to end up being at center -4 3 and then a radius of 4. I'm going to put that in parentheses. Radius of 4. So that one can, like I say, can be trickier. You could have to look at this and then say, oh, well, you know, I know that if this is a chord on this circle. By the way, this is kind of what we're working with, is this circle here. If this is a chord on that circle, we know if we go perpendicular bisector on it, it's going to go through the center. And if this chord is on the circle, the perpendicular bisector goes through the center, and you might have to find a center by using a couple of the intersection of 2 perpendicular bisectors. So we can maybe take a peek at one of those for a more challenging problem. Either way here, though, we've got our center at -4 3, so it's going to be x minus -4, so it ends up being +4 squared, plus y minus 3, so y minus 3 squared is equal to our radius squared, which is 16. And so that would give us that. And we should be able to plug all those points in. I haven't done this yet, but you should be able to plug in -8, 3, and this thing works out. So -8 is -4, squared is 16. If we square that, and then, yeah, it ends up being 3. Works out to make that 0 and adds up to 16. You should be able to plug in -4, 7. So -4, that's going to be 0, and then 7 minus 3 squared is 16. So 4 squared is 16. That works out. And then -4, 1 should work as well. So -4 here, that ends up being 0. 1 minus 3 is -4, squared is 16. So all those points work out if you plug them in.